Okay guys, so today we are going to be evaluating an integral from the 2018 MIT Integration B qualifier test, which is the integral from 0 up to 2018 pi of the absolute value of the sine of 2018 x with respect to x. You can tell that it was given in 2018, absolutely. So how are we supposed to solve this integral right there? Well, first of all, I'd like to get rid of this year of the competition inside the sine of x. So I'd like to propose you guys a u sum that will set 2018. Is this line straight? Oh no, it isn't. Lol. So 2018x being equal to a u, and so then 2018 dx being equal to du, and now as for the bounds, we get that whenever x is equal to 0, u is going to be equal to 0 as well, but if x is equal to 2018 pi, well then u is equal to 2018 squared multiplied by a pi, and so those are our bounds. This is our u sub. We can move forward, we're going to proceed using this u sub absolutely and perfectly. So as we're multiplying the dx by 2018, we have to multiply the entire integral by a 1 over 2018. It's going to look something like this. So 1 over 2018 times the integral between 0 and 2018 squared times, not times x, bro, times pi. That's all going to be taken of the sine of u. In the absolute value, it's all gonna be du. Okay, so now, absolute value, hate this guy. So how are we supposed to proceed further, given that, well, we can't really integrate something that is not quite differentiable, and you see most of the functions that are, not only defined on the real number and on the positive real numbers like sine itself, because it goes, from -1 up to 1, it just kind of oscillates around the x-axis. It is not going to be quite differentiable on that, on its domain when we are taking the absolute value of it. So how is it actually going to look like? Well, I would like to draw it out. So this is going to be my coordinate system, yes. So this sine will look, it's going to look something like this. Is my beautiful sine wave, yeah. So it crosses the x-axis of the pi, it gets to its maximum and minimum values, so -1 and a 1, a -1 and a 1, at pi over 2, at 3 over 2 pi, and all that stuff, yeah. And now if I were to draw myself the sine, the absolute value of sine, so that was my sine of u, that was u, that was, let's say, y. And I'd like to draw myself the absolute value of the sine of u. I just have to kind of take this part right there and just flip it around the u-axis, getting something, oh no, it's awful, something like this, let's say, yeah? So what I'm actually trying to integrate, what kind of area I'm actually trying to get, is the area of those, little bumps, those little mountains, let's say, on the u-axis. And the nice thing is that because those little bumps begin at some kind of how to say it, at a number that is divisible by pi, and they end at the number that is divisible by pi, yeah? So they have an interval length of just a pi, and our integrations bound are, in terms of pi, so 0 times pi and 2018 squared times pi, we just kind of say that we will integrate 2018 squared, so quite a lot of those bumps. But now, what is the area under a single bump like this? Well, the area under a single bump, I'm gonna draw it. I'm gonna mark it like this. So this area there is just the integral between 0 and a pi of just the regular sine u du, which is just negative cosine of u between 0 and a pi, and so that will just evaluate to a 2. Yeah. So the area of a single bump is a 2. Well, that's lovely, because we've just said that this integral here just represents 2018 areas of such little bumps. So we can just kind of say that we will get this entire thing being equal to, I'm just going to write this 1 over 2018 from here. Now I'm going to just say that this thing is equal to 2018 squared multiplied by the area of a single bump, which is a 2. Now this exponent here is just gonna cancel out with this 1 over 2018, and what we will end up with is just 2018 multiplied by 2, which is... Shit, bro, it should be 4036 if my arithmetic's up to date, but it surely isn't, honestly. So once again, what did we do in order to solve this problem? Well, first of all, we got rid of that 2018 in the sign itself. I don't really like having constants inside of trigonometric functions. Changing bounds of integration was also pretty important there. And then what we did is actually we kind of just plotted the function. We noticed that what we're trying to evaluate is just a bunch of small areas under some bumps on the u-axis, and then we just interpreted the integral as such and multiply what we had to multiply through by what we had to multiply through, and got our answer. Hope you guys enjoyed it, and see you next one. Bye.